On July 1st, 7 miles of 7 billion-year-old ice came screaming into our solar system at 130,000 meters an hour. This isn't just another space rock. This is water ice older than Earth itself, preserved in the cosmic deep freeze since before our sun was even born. We're about to witness the coma of an ancient comet, examine ice from alien star systems, and decode messages written in starlight from the early galaxy. But we have just months before it vanishes forever behind our sun. Hit that like button and subscribe because you won't want to miss this cosmic time capsule. Prepare yourselves. We begin. Music. The telescope in Chile was doing what it does every clear night when everything changed forever. On July 1st, 2025, the Asteroid Terrestrial Impact Last Alert System was scanning the southern sky for dangerous space rocks. Just another routine survey of the cosmic neighborhood. The automated system captured thousands of images, processing them through algorithms designed to spot anything moving against the background stars. Most nights, it finds asteroids, sometimes comets. This night, it found something that shouldn't exist. The object appeared as a faint dot barely visible against the dense star fields near the galactic center. Like finding a single firefly in a stadium full of Christmas lights. What made astronomers stop and stare wasn't how it looked. It was how it moved. This thing was racing across the sky faster than anything they'd seen before, covering distances that would take normal solar system objects weeks to cross. The initial observations showed speeds of over 60 kilometers relative to our sun. That's fast enough to circle Earth in just 11 minutes. Numbers like this don't happen by accident. Objects moving this fast can only mean one thing. They're not from around here. Within hours, observatories around the world were turning their instruments toward this mysterious visitor. The Zwicky Transient Facility in California found it in their archives. The Canada-France Hawaii telescope spotted its faint glow. Each new observation confirmed what astronomers were starting to suspect, but hardly dared to believe. This wasn't just another asteroid tumbling through space. The trajectory calculations showed something extraordinary. The object was following what scientists call a hyperbolic orbit, meaning it would never loop back around our sun. It was passing through our solar system like a cosmic tourist here for a brief visit before continuing its journey into the infinite dark. The Discovery team initially gave it a temporary designation, 11Pol-3s, a cryptic code name for what would soon become one of the most important astronomical discoveries of the decade. As more telescopes joined the hunt, the evidence became undeniable. This object had traveled between the stars for millions, possibly billions of years before stumbling into our neighborhood. The Minor Planet Center, the official authority for cataloging cosmic visitors, needed just 24 hours to make it official. On July 2nd, they announced the confirmation. Humanity had found its third known interstellar object. The designation changed from that cryptic code to something far more significant. 3 Atlas. The 3 marking it as the third interstellar visitor we'd ever detected. Think about that for a moment. In all of human history, we've confirmed exactly 3 objects that originated beyond our solar system. This cosmic messenger joined the legendary ranks of Oumuamua and Boris. Yet, even among these rare visitors, this new arrival would prove to be different, special, ancient. The discovery was just the beginning of the story. But what the telescopes revealed next would challenge everything we thought we knew about the age and composition of interstellar space. This cosmic visitor almost slipped through our fingers completely unnoticed. Amateur astronomer Sam Dean was digging through telescope archives when he made a startling discovery. The object we now call 3 Atlas had been hiding in plain sight for weeks, captured in images dating back to June 14th. 20 separate observations sat in computer databases waiting for someone to connect the dots. The object had been photographed dozens of times before anyone realized what they were looking at. Why did it take so long to spot? Picture trying to find a moving star in the most crowded part of the night sky. The object was traveling directly in front of the galactic center, where millions of stars create a brilliant backdrop of cosmic confusion, like searching for a black cat in a coal mine during a power outage. The dense star fields of Sagittarius had provided perfect camouflage for this interstellar intruder. Every image showed countless points of light, making it nearly impossible for automated systems to distinguish between distant stars and this nearby visitor. The discovery algorithms kept dismissing it as background noise. Time was running out faster than anyone realized. Unlike asteroids that hang around our solar system for millions of years, interstellar objects are cosmic sprinters. They race through our neighborhood at breakneck speeds, visible for just months before disappearing forever. Miss your chance, and you'll never get another. The situation grew more urgent when astronomers calculated the viewing window. This object would remain observable from Earth only until September, when it would pass too close to the Sun to study safely. That gave the global astronomy community roughly 10 weeks to unlock the secrets of a visitor that had traveled between the stars for eons. Observatories worldwide launched into action like a coordinated emergency response. The Hubble Space Telescope cleared its schedule. The James Webb Space Telescope prepared infrared observations. Ground-based telescopes from Chile to Hawaii began round-the-clock monitoring. Every clear night became precious. The European Southern Observatory deployed their very large telescope array. 4 massive mirrors working in perfect synchronization, creating the equivalent of a single telescope 25 meters across. In Japan, the Subaru telescope joined the hunt. In Spain, the Grand Telescopio Canarias turned its 10-meter mirror toward the mysterious visitor. Even citizen scientists joined the race. The Unistellar network, made up of hundreds of small telescopes operated by amateur astronomers, began tracking the object. Despite using instruments just 3 to 4 and across, these dedicated observers successfully captured images by stacking multiple exposures together. The clock was ticking in more ways than one. Not only would the object soon vanish behind our sun, but its distance from Earth was constantly increasing. Every day that passed meant dimmer images and fewer photons reaching our detectors. Like trying to photograph a candle that's being carried farther away every second. The astronomical community had stumbled upon a cosmic time capsule, and they had just weeks to decode its ancient secrets. What they discovered about its incredible speed would reveal clues about an unimaginably violent cosmic event that launched this visitor toward us. 7 meters of ancient ice and rock were hurtling toward our inner solar system. When the Vera Rubin Observatory analyzed their archived images, they uncovered something astronomers hadn't expected. Hidden in photographs taken on June 21st, before anyone knew to look for it, lay clear evidence of this object's true scale. The images revealed a nucleus roughly 7 meters across, making it a genuine giant among interstellar visitors. To put that in perspective, imagine Manhattan Island carved out of primordial ice and rock, then hurled between the stars for billions of years. The previous interstellar visitors were cosmic pebbles by comparison. Oumuamua stretched just 400 meters, about the length of 4 football fields. Boris measured less than a mile across. This new arrival dwarfed them both. The size revelation came from careful analysis of the object's brightness and the way sunlight scattered off its surface. Like forensic investigators reconstructing a crime scene from tiny clues, astronomers used photometry to determine dimensions of something 400 million miles away. The calculations showed a nucleus with a radius of 3½ miles, give or take just 0.4 of a mile. Size matters in the cosmic realm, and this discovery changed everything. Larger objects retain their internal heat longer, keeping volatile compounds like water ice, carbon dioxide, and methane locked away in frozen storage for eons. A 7 millimeters wide comet could preserve materials from its birth star system virtually unchanged, creating a natural time capsule of ancient chemistry. The Rubin Observatory had captured these crucial images using what astronomers call the legacy survey of space and time. Over 100 separate photographs taken during a 2 period showed the object's steady movement against background stars. The telescope's massive 3.2 billion pixel camera could detect objects a billion times fainter than what human eyes can see. But the size wasn't the only surprise hiding in those archived images. The data revealed something even more intriguing. The object was already showing signs of activity while still incredibly far from the sun. A faint coma of gas and dust surrounded the nucleus, proof that this ancient visitor was beginning to come alive. Most comets from our own solar system remain dormant until they get much closer to our star. This object was releasing material while still beyond the orbit of Jupiter, suggesting it contained highly volatile compounds that sublimate at extremely low temperatures, like a deep freeze that had been unplugged after 7 billion years of storage. The discovery team realized they were looking at something unprecedented. Previous interstellar objects had been studied only as they raced away from our sun, already depleted of their most interesting materials. This time, astronomers were catching an ancient comet in the act of awakening, watching as billions of years of accumulated ice began transforming directly from solid to vapor. The size revelation promised even more dramatic developments as this cosmic giant continued its approach toward the inner solar system. The real question wasn't how big it was, but how fast something this massive could possibly be moving through space. 130,000 miles per hour and still accelerating. This ancient visitor was moving faster than anything astronomers had ever tracked in our solar system. To understand just how impossibly fast that is, imagine a bullet that could travel from New York to Los Angeles in less than 90 seconds. That's the kind of velocity we're dealing with when we talk about interstellar objects. The speed measurements came from carefully tracking the object's position against background stars over several nights. Like cosmic radar, astronomers used the Doppler effect to measure how quickly it was approaching us. The radial velocity reached 61 kilometers/, fast enough to escape the gravitational pull of our entire galaxy if it were pointed in the right direction. This wasn't just fast for a comet. This was fast for anything. The space shuttles reached their maximum velocity at just 5 meters per second during orbit. The fastest human-made object, the Parker Solar Probe, tops out at 430,000 miles per hour when diving close to the sun. This interstellar comet was moving at nearly 1/3 at speed without any help from rocket engines or gravitational slingshots. What could accelerate a 7 meters wide chunk of ice and rock to such incredible velocities? The answer lies in one of the most violent events the universe can produce: stellar encounters. When this object was still part of another star system billions of years ago, something catastrophic happened. Perhaps two stars passed unusually close together, their combined gravitational fields acting like a cosmic catapult. Or maybe a massive planet migrated inward, disturbing the outer reaches of its system and flinging countless comets into the void. The ejection process requires precise conditions. Too little velocity and the object never escapes its home system. Too much and it gets torn apart by tidal forces. This visitor hit the cosmic sweet spot, receiving just enough energy to break free while remaining intact for its billion-year journey through interstellar space. As it continued approaching our sun, the gravitational acceleration would increase its speed even more. By the time it reached its closest approach in late October, it would be screaming through space at over 200,000 miles per hour, fast enough to cross the entire continental United States in just 55 seconds. The hyperbolic trajectory told astronomers this object would never slow down enough to be captured by our sun's gravity. Like a marble rolling down a curved ramp, it would sweep through our solar system once and continue into the cosmic dark forever. This was a one-time only performance, a brief cosmic concert that would never be repeated. The speed also created technical challenges for observation. Telescopes had to track the object's rapid motion across the sky, constantly adjusting their pointing to keep it in view. Like trying to photograph a race car from the grandstands, the tracking systems worked overtime to capture clear images of this fast-moving target. These incredible velocities held clues to something even more remarkable: the object's mind-bending age, 7 billion years old. This cosmic wanderer predates our entire solar system by 3 billion years. University of Oxford astronomer Matthew Hopkins ran the calculations multiple times, hardly believing the results. Using computer simulations to trace the object's trajectory backward through galactic history, his team discovered something extraordinary. This visitor likely formed when the universe was less than half its current age during an epoch when the Milky Way looked completely different. Think about that timeline for a moment. When this comet first condensed from the disk of gas and dust around an ancient star, Earth didn't exist. Our sun was still just a cloud of hydrogen floating in space. The entire solar system was nothing more than raw materials scattered through an unremarkable patch of the galaxy. Yet, this object was already fully formed, beginning its billion-year journey through the cosmic void. The age calculation came from analyzing the object's steep trajectory through our galaxy. Unlike previous interstellar visitors that traveled roughly parallel to the galactic plane, this one approached from a sharp angle, suggesting it originated from the Milky Way's thick disk. This region contains the galaxy's oldest stellar populations, ancient suns that formed when the universe was young and metal-poor. Stars in the thick disk are typically 7 to 10 billion years old, making them senior citizens compared to our 4.6 billion-year-old sun.